Hello, guys. Welcome to Ramta Solutions. Welcome to your lesson on probability. Today, we are looking at counting principle. Okay, we are looking at counting principle. So, we're going to introduce what is counting principle and also do examples to show you how to apply counting principle. And those examples will be for non-repeating outcomes and repeating outcomes. So you will see that shortly. Okay, so this will be one interesting topic. Remember, the maths that you're doing maths to solve processes for you. You don't want to be working forever and ever. You want to be working efficiently. All right, so this is why you're doing counting principle. Now, what is counting principle? So counting principle, you encounter it in this way. I want you to imagine this. When you are, imagine you're tossing your coin so many times. Okay, let's say you're tossing your coin 15 times. Obviously, each time when you toss a coin, you have a head or tail. Right? You have a head or tail. So far, because now you're in grade 12, you have been using a tree diagram to simplify your workings, right? Especially when you have outcomes. The tree diagram is conducive when you have a small sample size. For example, if you were looking at maybe 2-3 outcomes, it would be easier to draw a tree diagram, right? But if you were to look at maybe 10 to 15 events, it would be difficult to draw a tree diagram. So this is why we're introducing counting principle. So now, counting principle, how it goes, it's like this. So we're saying if one operation can be done in M ways, I want you to highlight this. If one operation can be done in M ways and another in N ways, then the total number of ways in which both operations could be done is M times N. Okay, so the total number of ways in which both operations can be done is M times N. Okay, you are going to understand this shortly. You're going to understand this shortly, or maybe let me write it in this way. Total outcomes, or total of outcomes. Total of outcomes would be M outcomes multiplied by N outcomes, or N ways. All right? So what is happening here is that, for example, let's say you toss your coin 2 times. On the first time you toss a coin, you will be getting head and tail. The second time you toss that coin, you will still be getting head and tail. But the possible outcomes that you can get could be head and head, head and tail and head, or tail and tail, meaning there are 4 outcomes. All right? So this is what fundamental counting principle is looking at. Remember, here we have limited it to 2 ways, but it can be over 2 ways. So in other words, if one operation could be done in M ways, another in N ways, another in O ways, another in P ways, you just multiply the number of times that operations are done. Okay? You just multiply this in the number of times that the operations are done. If you have 3 operations, okay, if you have 3 operations, it will be the product of all 3. Okay, it will be the product of all 3. Okay, so just like I've been saying, I said this procedure is basically taking over from your tree diagrams, because really, if you are dealing with a big sample space, your tree diagram will not be conducive, right? So, I mean, it's going to be wasting time. You don't want that. Okay, so I'm going to show you why we are doing this counting principle and why it's best. Okay, perfect. Now let's head into examples. Now our examples, we're going to look at non-repeating outcomes as the first example. So as an example, let's give you this. A canteen offers a meal consisting of choice 1, pap or rice. Let's do this. This is choice 1. It's pop or rice. So in other words, number of outcomes for choice 1 is 2. Then we call it C1. You don't necessarily need to be writing this C1, C2, blah, blah. That's just me to help you understand. So number of outcomes for this choice 1 is 2. Now let's look at choice 2. Choice 2 consists of chicken, beef, and what? And mutton. Right? And mutton. So number of outcomes for this choice 2, how many are they? They are 3. They are 3. Alright, so they are 3. Now, we then head to choice 3. Choice 3 includes salsa and chakalak. Right, includes salsa and chakalak. So that means number of outcomes for choice 3 is 2. Okay. Now, your question is saying, how many choices are possible? Remember, when you get to your canteen, you can say you want pap, chicken, and salsa, or you want chicken and chakalaka, or pap, beef and chakalaka, or whatever. You want to know what possible choices or arrangements are there. All right? So let's see. The question says, how many choices are possible? Now, question A, you must show these choices by doing manual calculation. I'm taking manual calculation because it's easier, okay? Because it's easier to just, it's easier to get this combination. But you will see why you are using a formula. Using a formula, it's simply because it becomes difficult when the sample size is big. Okay, so I'm going to do this. I'm going to say, I'm going to call pap P, I'm going to call rice R, chicken, I'm going to call it C, beef, I'm going to call it B, mutton, I'm going to call it M, salsa, I'm going to call it S, chakalaka, I'm going to call it C. Okay, it's another C, it's okay. All right, perfect. Now, let's see. Now, we are going to do number A. Number A says doing manual calculations. Let's see what are the choices that we have. So we can have pap, chicken, salsa, right? We can also have pap, chicken, and what? Chakalak, right? Let's see. Are we done? Yes. And then we can have pap, beef, salsa, pap, beef, chakalaka, or pap, mutton, salsa, or pap, mutton, chakalaka. Right? Perfect. Now, we then head to rice. We can have a rice, chicken, salsa, or rice, chicken, chakalaka, or we can have a rice, beef with salsa, or rice, beef with chakalaka. Again, we can also have rice, mutton with salsa. We can also have rice, mutton with chakalaka. Now, how many outcomes are here? How many outcomes are here? How many outcomes are here? Let's see. Let's count. 1, 2, 3, 4, 5, 6. So this is 12. Therefore, there are 12 outcomes. All right? There are 12 outcomes. Can you see that? So whoever who goes to the canteen can order any of this combination here. Right? Can order any of this combination here. Right? That's number A, pardon. That's number A. Now, number B, this is what we're going to do now. We're going to say total number of outcomes. We're going to use a formula. Total number of outcomes will be choice 1 multiplied by choice 2 multiplied by choice 3. How many options do you have for choice 1? I remember it was rice and pap. So there are 2 choices. How many did you have for choice 2? There were 3. It was chicken, beef, and mutton. So there were 3. How many do you have for choice 3? There were 2. It was salsa and chakalak. Now, what are your 2 times 3 times 2? That's 12. Right? That's 12. Right? That's 12. Can you see now? You have been, you were able to show this, you doing manual calculations. Now, you are able to do it using a formula. This is the formula that you know. This is your counting principle. Remember, I said it depends on how many events you have. In this case, we had 3 events. Hence, it's choice 1 multiplied by choice 2 multiplied by choice 3. Okay? Perfect. Now, I hope you guys were able to see this. Okay, so that was the first example. Let's try another one. So I'm saying non-repeating because none of the choice outcomes here are repeated. You're going to see the repeating ones. Now, let's then check the second example. So Mandisa has 5 skets. Let's get this. So I'm going to call skets. Okay, let me just say skets. She has 5, right? And then shirts. She has 3 shirts. Right? She has 3 shirts. And dukes. She has how many dukes? 3 dukes. And heels. In other words, shoes. She has 4 shoes or 4 heels. Now, how many attires can she make? So we can say total number of attires. All right, total number of attires. So total number of attires. So total number of attires will be 1. It will be skirts multiplied by shirts multiplied by dukes multiplied by heels. Can you see that? Multiplied by heels. So in this event of attires, we have 4 events. All right. So how many skirts does she has? She has 3 skirts, or 5, sorry, not 3, 5 skirts. See, she has 3 shirts, 3 dukes, 4 heels. Let's do this. 5 times 3 is 15, times 3 is 45. 45 times 3 must be 105. So total number of attires that Mandisa can make out of all these clothing items she has is 105. So when you look at this question, what it means is that 105 days of the year, when she decides to rock all these, she will be wearing different things. I don't know the kind of skirts she has, but she has 105 combinations. Okay, she has 105 ways in which she can wear all these clothes. So if you are thinking that you don't have clothes or you are poor, please note, mathematically, you can have different attires even with a number as small as this. Can you see that? You have 5 skirts, 3 shirts, 3 dukes, and 4 heels. Trust me, you can be stunning in 105 ways. All right. Now, that's another example. Now, example 3. How many words can be made from the word bite? Use manual calculation and a formula to verify your answer. Now, let's think about this. Bite. I'm going to say manual calculation. Manual calculation, bite. Manual calculation, or let me say manually. So manually, we can have B bite itself. We can also have BIET. Okay, we can have BTIE. we can have B, T, E, I. We can have B, okay, we can have B, E, T, I. We can have B, E, what? We can have B, E, I, T. Yeah, we can have B, E, I, T. And what else do we need? Okay, that's it. Now, let's start with I. We can have I. We can have I. Let me see. We can have I, B, T, E. We can have I. Let me reduce the sounds. We can have I, B, E, T. We can have I, E, B, T. We can have I, E, T, B. We can have I, T, B, E. We can have I, T, E, B. Then let's start with, let's also take, this time let me take E, starting with E. We can have I, B, T, I, sorry, E. E, B, I, T. And then we can have E, I, B, T. We can have E, I, T, B. We can now have E, T, B, I, then E, T, I, B. Lastly, we can have, I need to start with T. T, B, I, E, or T, B, E, I, T, I, B, E, T, I, E, B, then T, E, B, I, and then T, E, I, B. I believe these are all the combinations we can think of. So how many words can you make? Do you see? I was able to make 2, 4, 6, 6, 12, 18, 24. So you can make 24 words, right? You can make 24 words. This is manual calculation, right? This is manual calculations. You can make what? You can make 2 words, right? You can make 2 words, okay? I mean 24 words. Okay, you can make 24 words. Okay. Now, let's then look at using a formula. When we use a formula, this is an introduction to what you will term factorial notation. This is a 4-letter word. So check this out. 4-letter word. This is 1, 2, 3, 4. Now, what is happening for the first letter? For the first letter, you have 4 letters to choose from. All right? Now, if you have 4 letters to choose from, when you place that letter, what will be happening will be, okay, you have chosen 1 letter. So it means for the second letter, you will have 3 letters to choose from. All right? Now, on the second letter, you have 3 letters to choose from. You choose 1. How many do you have? That means you will have 1 less. So this means for the third letter, you will have 2 letters to choose from. All right? Now, for the fourth, because you had 2 letters to choose from for the third letter, you take 1 from 2, you're left with 1. So what is happening? This is 4 times 3 times 2 times 1. What is this? It will give you 24. Therefore, you have 24 words. Okay? You have 24 words. So this is an introduction to what we call factorial notation, which you will see shortly. Okay? Which you will see shortly. Okay? So now this is, as you can see, it's still factorial notation. Right? I mean, it's still counting principle. What does it mean? It means you have 4 events. For the first event, you have 4 outcomes. For the second event, you have 3 outcomes. For the third event, you have 2 outcomes. For the fourth event, you have 1 outcome. It's still factorial. Sorry, it's still counting principle. Can you see that? It's still counting principle. So this is how you work around these. Okay? This is how you work around these. Remember, this will be introducing what we call factorial notation, or it's introducing what we call factorial notation. which you are going to see shortly. Okay? Perfect. Now, if you are confused, do let me know, comment, and I will explain everything. Otherwise, you can contact us on WhatsApp. We will gladly assist you, or you can email us. We will gladly assist you. Okay? Perfect. Now, all right. Now, let's then talk repeating outcomes. When we talk repeating outcomes, let's say, for example, we have, now, remember we mentioned a tree diagram, that sometimes a tree diagram could be a tedious exercise, that we don't want to really use a tree diagram. It becomes a bit tedious, right? And nobody wants to be working inefficiently. Everybody wants to save time, right? So we mentioned that if you were to draw a tree diagram for tossing a coin 15 times, it'll be time consuming. And for some, it's boring. Like for myself, it's boring. Now, let's look at a better way. I'm going to show you how a tree diagram looks like for maybe tossing a coin 4 times. Let me show you. Tree diagram for tossing a coin, let's say 4 times. So it is head or tail, right? This is the first time I'm tossing. On the second toss, it's still head, tail. It's still gonna be head. Maybe let me imagine a bit. It's still head, tail. It's still head and tail, right? Now we go into the third toss. It's still head, tail, head, tail. It's still head, tail. It's still going to be head, tail. Now, I want to show you. Now, fourth toss. Head, tail, head, tail. I want you guys to see this. I'm aware that I am squeezing it, which makes it, but okay, you will get my point of why I'm using it. I'm doing it like this. Head, tail, head, tail. Okay, and then head, tail, and then head. Let me fix this. Tail, and then here, head, head, and tail. Can you see that? Now check this out. This is the first time you are tossing a coin. This is the second time you are tossing a coin. This is the third time you are tossing a coin. And this is the fourth time you are tossing a coin. Okay. Now the total outcomes are head, 4 H's. And head, tail. Right? Tail. Now we have head, tail, head. Head, tail, head. And then we then have head, tail, tail. Head, tail, tail. Already some of you can see where we're going. Now we then head to head, tail, head. Head, tail, head. Head, tail, head. Head. Alright. You guys will appreciate what I'm trying to do later. For now, please bear with me. It looks untidy, but please bear with me. Head, tail, right? It's head, it's head, tail. I'm done. It's head, tail, head. Head. It's head, tail, head. And then it's head, tail. Head, tail, tail. Right? Head, tail. We're done. So it's 8. Now it's tail, head. Tail, head. Tail, head, tail. Tail, head, tail. And then it's tail, head. It's tail, head. Tail, head. Tail, head. And then it's tail, head, tail. Tail, head, tail. Here was it. Tail, head, tail. Now it's tail, head. Tail, head. Tail, head, tail. Tail, head, tail. Now it's tail, head. tail, 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 head. Oh, sorry, tail, tail. Tail, 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 head. Lastly, tail, 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 tail. Now, something that I want you guys to look at is that I said it'll be time consuming and boring. I want to highlight these words here. Let me highlight these words here. Not that they're important. You guys must somehow be agreeing with me that doing this was time consuming and chiefly it was boring. You end up making a mess, right? You end up making a mess, right? You end up making a mess. So this was a boring exercise. But how many outcomes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? 16. But isn't there a better way of doing this? Now, this is why you are doing mathematics and why you are doing counting principle. And I'm going to show you now. Let's go. Now, you have seen that this is not really working, right? It wasn't working. Now, I'm going to show you that, doing a tree diagram wasn't showing. But I can show you now total number of outcomes, right? Total number of outcomes could be easily written as 1. We had event 1, which is tossing the coin the first time. How many options do we get? We get head and tail. How many are there? 2 outcomes. When we toss the coin the second time, what are we getting? We still get head and tail. It's still 2. When we toss it the third time, it's still head and tail. They are 2. When we toss it the third time, what are we getting? The fourth time. What are we getting? We still get head or tail, right? Now, when you look at this is 2. When bases are the same, you add exponents. This is 2 to the 1 plus 1 plus 1 plus 1, which is 2 to the 4. Do you see that? Now, we know this is 16. 2 to the 4 is 16. If you are not sure, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Right? There is a reason why I did this. There is a reason why I did this. And pay particular attention to this point here. Pay particular attention to this point here. We have 2 outcomes, right? We have 2 outcomes. We have 2 outcomes, but repeated 4 times. Right? Repeated 4 times. Do you see that? We have 2 outcomes, but repeated 4 times. Right? Therefore, we can generalize this and say, generally, total number of events when events are repeated are, or total number of outcomes, if you like. Total number of outcomes would be n to the power r. What is n? N is the number of outcomes, okay? N is the number of outcomes, and then r is the number of times event is repeated. Number of times event is repeated. Okay? Number of times event is repeated. Okay? Remember, when events are repeated, you can simply say number of outcomes to the power whatever number of times that event is repeated. Okay? For example, for tossing the coin 4 times, it was 2 to the 4 because it was repeated. We tossed the coin 4 times. And obviously, every time when you toss a coin, you either get a head or a tail. Okay? Right. Perfect. Now, let's try examples. Now, how many word arrangements are possible if alphabets of the word bite can be repeated? Now, you can get B, 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 B. Right? You can get B, I, 3 I's. For example, let me just show you what I mean. E.g., you can get B, 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 B. Or you can get B, I, or you can get byte itself, right? You can get B, T, T, E, and so on. But we cannot be doing that right now. We don't have the time. Because we know a formula, we can say our answer is simply word arrangements would be byte 4 outcomes, right? But because we are making a four word arrangement, for the first letter, it'll be one of the 4. For the second letter, it'll be again one of the 4. For the third letter, it'll still be one of the 4. For the for the fourth, it'll still be one of the 4. Remember, they said they can be repeated. So it can be whatever, they can be repeated. So what does it mean? This means we can have, this is just for demonstration, but for our answer, it means we can have 4 to the 4. That is our answer. Okay? We can have 4 to the 4. Okay? We can have 4 to the 4, which is 256 words. Okay? We can have 256 words. Okay? We can have 256 words. But, it's not no, I shouldn't be saying but. However, pay attention to this. I do not have the time to be doing manual calculations of these words. This is why we use the formula. And if a formula gives you a tough time, you ask yourself, you can do these dashes. All right? You can do these dashes. When they say the word byte can, if alphabets of this word can be repeated, it means this exactly. For the first, I repeat, you have 4 letters to choose from. When you choose a letter, it doesn't reduce the number of letters you have to choose for the next letter, right? Because they say they can be repeated. Now, again, for the second letter, you still have 4 to choose from. For the third, you still have 4 to choose from. For the fifth, for the fourth, third and fourth, you still have 4 to choose from. Hence, this is 4 to the 4, which is 256 words that can make up, 256 words that can be made up from the word byte if the alphabets can be repeated. Right? Perfect. Now, number 5, they say a school soccer team plays a soccer league. How many results are possible for the school if they play 5 games? Remember, I'm mentioning here a league. For a league, you have these outcomes. You have these outcomes for a league. A team can either win, they can lose, or they can draw. So there are 3 outcomes. Now your answer will be 3 outcomes, but they play 5 games. So this means it'll be 3 for the first game, for the second, 3 outcomes, for the third, 3 outcomes, for the fourth, 3 outcomes, for the fifth, 3 outcomes. Right? When you look at this, what is it? This is 3 to the 5 possible results. Let's see. So let's see, 3 to the 5. That's 243. Right? That's 243 results that are possible. Okay? That's 243 results that are possible. So if you are wondering, your team, meaning your school, if you are from Bakwena or Todi High or Central Secondary or Brett's School, your team could have played win, win, win. Or they could have played win, win, draw, or win, win, lose, or win, lose, draw, or draw, 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 or lose, 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 and so on. Do you guys see that? And so on. So we do not have the time to be drawing 243 results. There are many ways that your teams, 5 games. This is 5. This is 5. So it should be, okay. Okay. Okay, so let me just do it like this. So I don't have the time to be drawing 243 results. right? So your team could be this, could be this, could be whatever, right? We don't know. They could lose all 5 games, or they could win one, but which one are they winning? Are they winning the first, the second, and lose the rest? So we don't have the time to be drawing all these, but we can simply do this. Okay? We can simply do this. Okay? We can simply do this. All right. Perfect. Now, let's see. A multiple choice question paper of 20 questions consists of 5 options A, B, C, D, and E. How many ways are there for answering the question paper? This one, you shouldn't be struggling with it. Right? You shouldn't be struggling with it. It's easy. It's easy. Indeed, it's easy. Why? How many outcomes are there? There are 5 outcomes, but how many times are you repeating them? 5. How many times are you repeating them? 20 times. As simple as that. That's your answer. When you press 5 to the power 20, your calculator will be giving you correct to 2 decimal places. It will be giving you 9,54 times 10 to the 13 ways. Right? Remember, you have 5 outcomes, but those outcomes you're repeating them 20 times because you have a multiple choice question paper of 20 questions. Right? So your outcomes are A, B, C, and D, meaning those are your choices. Right? Those are your choices. So imagine if I were to say the order of your answers could be A, B, 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 B. I mean, 9.54 times 10 to the 13 ways. Guys, I'm not going to finish if I were to do that manually. Right? And the beauty of it is you have a formula. Right? The beauty of it is you have a formula. All right. Cool. Let's go. Now, let's see. We have, let me see how far, okay, how much I have. Okay. Now we have, let's see, we have a password is to be made up using the format triple X and double Y, where X represents digits 0 to 9 and Y represents letters of the alphabet. How many different passwords can be made in each of the following cases? Okay. Now, note, X represents digits 0 to 9 and Y represents letters of the alphabet. Okay? So what we have, X is 0 to 9. Right? X is 0 to 9. That means number of outcomes of X is 10. Y is A, B, C until Z. Right? Until Z. That means number of outcomes for this is 26. Okay? Because we have 26 alphabets. And again, when you have 0 to 9 numbers, that means you have 10 numbers. Okay, perfect. Now, number A, how many passwords can be formed in each of the following cases? Now, they say digits and letters can be repeated. Remember, digits and letters can be repeated. So number A, we have 1, 1, 1 digits and alphabets 1, 2. So if they can be repeated, they didn't give us any restrictions. How many numbers do we have to choose from? It's 10, right? And they say they can be repeated. So this means the number that I choose, it doesn't affect the occurrence of the second. So it's still going to be 10 for the second. It's still going to be 10 for the third. For the alphabets, it's 26 alphabets. So my choice of an alphabet does not affect the choices that I have because they said they repeated, I can still repeat that alphabet. So it's 26, right? So you take your calculator and you say, this is 10 times 10 times 10 times 26 times 26. What is it? Let's see. With me, I'm simply going to say this is 10 cubed multiplied by 26 squared. This is 676,000. What are we doing? Okay, so what we have is 676,000 passwords. Okay, passwords. Okay, as simple as that. Number B, let's see. Digits and letters may not be repeated. Perfect. Remember 1, 2, 3, 4, 5. We choose a number. For the first number, we have 10 to choose from. Now, since we cannot repeat it, that means we no longer have 10 but 9, and then we no longer have 9 but 8. Right? For the alphabets, we have the first alphabets, we have the whole 26 alphabets to choose from. When we have chosen an alphabet, it is out. We no longer have 26, but this time we have 25. So what do we have? 10 times 9 times 8 times 26 times 25. Alright? Times 25. So how many passwords can we form if this is the procedure that we should follow? So here we will have 468,000 passwords. Okay? 468,000 passwords. Okay? Perfect. Now, let's see. Digits and letters may be repeated, but the number 0 and the vowels must be excluded. So this time around, what it means, we don't have 0. So if we don't have 0, this means these guys are no longer 10 digits to choose from, but 9. Then we don't have vowels to choose from. So since we don't have vowels to choose from, vowels are Kasetswana, A, E, I, O, U. They are 5, right? So this means we no longer have 26 letters to choose from, but 21, because A, E, I, O, and U are out, right? They are out, right? So what do we have? We now have 21 alphabets to choose from. Now, underline this. They may be repeated, but number 0 and vowels must be excluded. Let's go. So what we have? 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5. So for the first digit, we have 9 to choose from. For the second, we have 9. For the third, we have 9. Alphabets, we have 21, 21, right? So how many passwords can we make? 9 times 9 times 9 times 21 times 21, which is, in your calculator, you will be saying 9 to the 3 times 21 to the 2, which is 321,489 passwords. Okay, passwords. For this condition, number C, where they say digits and letters may be repeated, but 0 and the vowels must be excluded, you will have 321,489 passwords. Okay? All right, perfect. Let me just do this. All right, let me just do this. All right, and then I'm not sure if I will have enough space, but okay, let me just do this. Okay, now let's go to number D. Number D, let's see what it says. It says, digits and letters may not be repeated, but the number 0 and the vowels must be excluded. Again, they are now 9 because we no longer have 0. And these guys are now 21 because we no longer have vowels. Right? So 1, 2, 3, 4, 5. They said may not be repeated. All right? May not be repeated. Okay, so that means we have 9 digits for the first digits. Now, because they may not be repeated, this means whatever that we chose reduces the next by 1. So we will have 8, and then here we will have 7. Now for alphabets, we have 21, but because they may not be repeated, we now have 20. Okay. Now, what is our answer? 9 times 8 times 7 times 21 times 20 times 20. What is it? 9 times 8 times 7 times 21 times 20. It is 211,680 pass weights. Right? Pass weights. Okay. Perfect. Let's go try number E. Digits may be repeated, but must be prime numbers, and alphabets may be repeated, excluding the first 5 letters and the last 5 letters. It's okay. Prime numbers. Let's talk prime numbers. E, let's talk prime numbers. So X, we talk in prime numbers, numbers that can be divided by 1 and themselves. That's 2, 3, 5, 7. That's it. Therefore, that means you have 4 numbers. And then alphabets, the first 5 and the first 5 and the last 5 are out. So that means you now have 26 minus 10, because first 5 and last 5, that's 10. So this means you have 16 alphabets, right? This means you have 16 alphabets. Okay? Right. So now they said they can be repeated, right? They can be repeated. Okay? Digits and alphabets can be repeated, right? Okay, let's go. So we have 1, 2, 3, 4, 5. So for the first, we have 4 to choose from. It can be repeated, we still have 4. It can be repeated, we still have 4. Now, for the alphabets, we have 16. They can be repeated, we still have 16. So what is this? So this will be 4 times 4 times 4 times 16 times 16. Right? So let's see. 4 cubed times 16 squared. Our answer is simply 16,384 pass weights. Okay? 84 pass weights. Okay. So these are the pass weights, that the number of pass weights that you can make in that combination or in that process. When they say digits must be prime and repeat, alphabets must exclude the first 5 and the last 5. Okay? All right. So this is it, guys. Due to load shedding, I'm going to be load shedding in a few minutes. I'm gonna do this portion shortly after load shedding. Okay, so this is it. Hello guys, we are back. Yes, we now have power. So we were done with this question. Let us go to the next question. Question 8 says, in 2010, Gauteng province ran out of number plates with the format LLDD, where L is any letter excluding vowels and Q, and D is a digit between 0 and 10. Now they say the new number plate has the format LLD, LL. For all formats, the old and the new, letters and digits are repeating. Now, let's look at how many letters did we have in the old and the new. So we are excluding vowels. There are 5 vowels, all right? So it's A, B, C, and so on until Z. But excluding A, E, excluding vowels, maybe let me say this, there will be, when we have them like this, it'll mean we have 26. But when we exclude vowels, remember vowels are A, E, I, O, and U, right? And Q. What will we have? We will have 20 letters to choose from, right? We will have 20 letters to choose from, right? Now, this is because vowels, there are 5 vowels, and Q together, this makes it 6. Now, 26 minus 6, it means we have 20 letters to choose from. Then, on the digits, we have 0 to 9, which means we have 10 digits to choose from, right? We have 10 digits to choose from, okay? Perfect. Now, they say the new number plate has the format double L, double D, double L. It's okay? And these letters and digits are repeating. So, the first question says, calculate the total possible number plates of the old format. Number A, total number plates. So total number plates are, we had triple L and then triple D, right? So they said these letters and digits are repeating. So this is how many letters? 20, 20, 20. And the digits, how many are they? 3. And we have to choose from 10 digits. So it's 10, 10, 10 because they are repeating. Therefore, this means we have 20 times 20, or maybe let me write it neatly. This is 20 times 20 times 20 times 10 times 10 times 10. You take your calculator, what are you getting? Let's see. I will say 20 cubed times 10 cubed, which is 1,000. So we are getting 8 million, right? We are getting 8 million, right? So the total number plates we can get in the old system is 8 million, right? It's 8 million. Now we are done with the first question. Now question B says, calculate the total possible number plates of the, okay, this should be the new, let's say new format, okay, of the new format, okay? Calculate the possible number plates of the new format. So let's go. Of the new format, let's see. For the new format, say, let's see. For the new format, B, we will say it's still LL, no, it's not still. It's LL, D, D, then LL. So, again, LL, remember it's LL, D, D, right? Okay, for the first letters, we have 20 to choose from. We also have 20 to choose from for the second because the letters and digits are repeating. We have 10 digits to choose from. We still have 10 to choose from. And then we have 20 letters to choose from. And again, 20. Remember, LL, DD, LL. And I'm saying 20, 20, 10, 10, and 20, 20 simply because the letters and digits are repeating. So the total number plate or total number plates possible, total number plates is 20 times 20 times 10 times 10 times 20 times 20. How many are there? So this is 20 to the 4, I will put it like that, times 10 squared, 100. So what is this? So now what do we have? We have 16,000, 16 million. We have 16 million number plates. With the new system, we have 16 million number plates. Okay? With the new system, we have 16 million number plates. Okay? All right. Now, question C says, how many more number plates are available for the new format, for the new number plate format? So, obviously, you compare the two, which one has the greatest number plates? The greatest number of number plates, it's the new system. So you will say for this answer, you will say for number C, you will say 16 million minus 8 million. Of course, the answer was readily available. What is it? It's simply 8 million, right? Therefore, to answer the question, you're saying there are 8 million more number plates available. Therefore, there are 18 million more number plates available. Okay, so the new number plate system has 8 million, not 18. The new number plate system has 8 million more number plates. Okay, has 8 million more number plates as compared to the old number plate system. Okay, right. So this is how you attempt this question, right? This is how you attempt this question. Okay, now let us go to example 9, and I believe it's the last example. So this one says, how many word arrangements are possible from the word Florida if the letters may be repeated? One thing you should know is that Florida has 7 letters, all right? And question A says they may be repeated. So to say they may be repeated, I'm still going to repeat. We're going to say we have, for example, if they may be repeated, we might have FFF, 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 FFF. I don't know what this word means. Remember, we're making words. So the word is and then we can also have FFF, FFF, FF. So what is this word? All right. And then we can also have another word, maybe for example, let me try TL Dolorifa, right? But come on, how many words can we make? I do not know. So we don't have to go this route. What I'm trying to show you here is that they're saying the letters may be repeated, okay? So in other words, for the, how many places do we have? 1, 2, 3, 4, 5, 6, 7. For the first letter, you have 7 letters to choose from. For the second, you have 7 to choose from. For the third, 7, and so on, right? Because what is this? Letters may be repeated, right? Letters may be repeated. So to answer your question, number of letters, number of word arrangements, right? Number of word arrangements could be, what is this? 7 to the 7. All right, as you can see, Florida is made of 7 letters, so it can be 7 to the 7. And what is 7 to the 7? 7 to the 7 is 823,543. So if we are repeating letters, Florida, if we are repeating letters, the word Florida can make up to 823,543 words. Okay, it can make up to that. So remember, this was just of what the question is asking you. These are some of the words that you might come across if they mean anything. Okay, so this is it. So remember, this is 7 to the 7. Okay, this is 7 to the 7. In other words, 7 times 7 times 7 times 7 times 7, which is 7 to the 7. Okay, perfect. Now, number B says the letters may not be repeated. Okay, perfect. Number B, if the letters may not be repeated, let's look at it. 1, 2, 3, 4, 5, 6, 7. So if the letters may not be repeated, we have Florida is made up of 7 letters. So for the first letter, when we choose 1, that means for the next letter, we will have 1 less, meaning we have 6. When we choose 1, it means we have 5. And then we choose 1, we are left with 4. We choose 1, we are left with 3. We choose 1, we are left with 2. We choose 1, we are left with 1. Therefore, what is this? Number of word arrangements here when the letters are not repeating, what are they? Would be 7 times 6 times 5 times 4 times 3 times 2 times 1. In the next video, you will learn about operations like these, okay? In the next video, you will learn about operations like these. We call them factorial notations, okay? We learn about notations like this, which we will call factorial notation. So this number, when you're done, it is 5040. So when the letters are not repeating, you can make 5040 weights. But if the letters are repeating, make 823,543. Okay? So this is your factorial notation, and I hope you guys will enjoy it, but not just enjoy, you will master it. Right. So with that being said, it's a wrap. See you next time. And listen, stay tuned for factorial notation. So, bye-bye.